And welcome back. As we go ahead and continue looking at our universe of astronomy, let's go ahead and look at that same universe, but on a large scale. So the universe is pretty enormous, but how enormous are we talking about? Well, astronomers can show that the universe is made up of enormous numbers of galaxies. A good way to kind of put this in context is think of our solar system as your house or apartment wherever you live, and the galaxy as the town in which you kind of belong to. And if you think about that, well, that town is made up of many houses and other buildings that compose it. So therefore, if we start thinking about it in that sense, we can therefore really define the universe to be everything that exists that is accessible to our own observations. Galaxies stretch as far into space as our telescopes can see, and many billions of them are within the reach of our modern instruments. Now, when galaxies were kind of first discovered, some astronomers said that these galaxy island universes looked more like islands of stars. And that's because, without our more modern tools, they did. They just kind of looked like a sea of stars out there in the vast dark sea of intergalactic space. Now, the galaxy that we live in is not alone. We have some actually neighboring galaxies that are very close to us. The nearest galaxy is a very small one that lies 70,000 light years from the Sun in the direction of the constellation Sagittarius. With the small of our own galaxy, it kind of makes it difficult to see. Now, beyond the Sagittarius dwarf galaxy lies two other small galaxies, about 160,000 light years away. These were first recorded by Magellan's crew as he sailed around the world and are often referred to as the Magellan clouds. You can kind of see them here in this picture here of these, dwarf galaxies here. Now, all three of these small galaxies are actually satellites of the Milky Way galaxy, meaning that they're interacting with it through the force of gravity. So they're kind of, effectively there in an orbit. However, just because they are there does not mean that they will always be there. All three of these galaxies may ultimately be swallowed by our much larger galaxy, as all other small galaxies have been over the course of time. Because a lot of times, what happens, these galaxies, they come together, force of gravity pulls them closer and closer and closer, and then they merge into a new galaxy. Now, another galaxy that is close by is the Andromeda galaxy. This is the nearest large galaxy. It is not orbiting ours, but it is a spiral galaxy, very similar to our own, and is located in the constellation of Andromeda, and therefore earns the name the Andromeda Galaxy. It's also sometimes referred to by its catalog number, M31, and it's a little more than 2 million light years away. Along with the Milky Way, it is part of a small cluster of more than 50 galaxies that we refer to as the Local Group. Now, the Milky Way, Andromeda, all these other ones are a lot of times can form into what we call galactic clusters. At distances from about 10 to 15 million light years, we can find other small galaxy groups, and then at about 50 million light years, we can actually see very impressive systems within thousands of member galaxies. And we can actually look at these and say, hey, these galaxies occur mostly kind of in like clusters. Sometimes the clusters are very big, sometimes these clusters are quite small. Again, if we look at this image, we can see a rich cluster galaxy some 4 billion light years away. This is also referred to as Pandora's cluster, and the grouping consists of many galaxies, and each galaxy, remember, is going to have billions of stars within it. Now, what if you have clusters of clusters? Well, we refer to that as a supercluster, because they can also form larger groups. So if you remember, we talked about our one group is the local group. Well, the local group is actually just part of another supercluster of galaxies, which we refer to as the Virgo supercluster, which stretches over a diameter of 110 million light years. Now, when we start getting into this kind of scale, it's very difficult to kind of fully grasp what it all is. And we're actually just beginning to explore the structure of the universe at these enormous scales. So when we start talking about superclusters, there's a lot of information here that we are just now being able to really dive into with our modern instruments. And we are already learning things that we didn't really expect to find there. One of the cool things that we can start learning, because at far distances, it's not as easy to see things, but we can see these things called quasars. At these great distances, all right, galaxies, when we are closer, we can kind of see them, we can kind of make out their patterns and stuff like that. But as you get farther away, they become very dim. But we can't find quasars. Well, what are quasars? Well, these are the bright centers of galaxies glowing with the light of a very extraordinarily energetic process. Now, the enormous energy of the quasars is produced by gas that is heated to a temperature that is millions of degrees, as it tends to fall toward a massive black hole and is swirling around it. Now, because quasars are so bright, they're so brilliant, it makes them pretty much the most distant beacon that we can see in the dark oceans of space. And they give us a good way to probe the universe that's at least 10 billion light years away or more. Or another way to think about it is a way of us to look 10 billion years into the past. So, can we view the beginning of time knowing this? Well, because quasars are so bright and we let us see so far away, we can really see back close to almost where the Big Bang explosion began that marked the beginning of time. Beyond quasars and the most distant visible galaxies, we've actually detected the feeble glow of the Big Bang explosion itself. That explosion, of course, filled the universe and comes to us really from all directions in space. It's kind of this background radiation that we can detect and use to kind of submit some information. Now, the discovery of this afterglow of creation is indeed one of the most significant events in the 20th century of science. And because it was so significant, we're still exploring the many things it has to tell us about some of the earliest times in the universe. Now, obviously, for us to be able to look deeper, we're going to need tools that are going to allow us to view deeper. Measurements of the properties of galaxies and quasars in remote locations require large telescopes. They have sophisticated light amplifying devices, and of course, to make all this stuff requires painstaking labor. Now, every clear night that happens, astronomers and students are hard at work. They're out there trying to figure out the mysteries of the universe, such as how's the birth of new stars and the large-scale structure of the universe, going everything from our solar system up to the superclusters that we talked about. And they're trying to make sure that these things can fit the results into the tapestry of understanding, making sure that those scientific models that we talked about actually work. Because if they don't work, that means that we need to go back and look at our hypotheses, our theories, and maybe we have to modify them or create new ones.